Good afternoon. My name is Bob Armstrong, and I'm director of the MIT Energy Initiative, or MITI as we call it. And it's my very great pleasure to welcome you this afternoon to our MITI seminar. MITI is MIT's hub for energy, research, education, and outreach. And the seminar series serves an important role in all three of these major themes. Through the seminars, we seek to bring leaders in energy to campus, and at least virtually, as is the case here, to engage with us around timely and important issues affecting our mission, which is to meet growing energy needs of the world, particularly for those who are currently severely underserved, while at the same time mitigating climate change. Today, we're very pleased to have with us Dr. Deborah Gordon, who is a senior fellow at the Watson Institute at Brown University. Before that, until 2019, she was director of the Energy and Climate Program at the Carnegie Endowment for International Peace. She was trained as a chemical engineer and a policy analyst, and her current research focuses on the development of the Oil and Gas Climate Index, which is a first of its kind tool to compare the climate impacts of global oils and gases. After beginning her career at Chevron, Debbie directed the energy policy program at the Union of Concerned Scientists, taught and conducted research at Yale School of the Environment, and managed an active energy and environmental consulting practice. She's author of 2 books, Steering a New Course and 2 Billion Cars. And she's currently working on her next book about managing oil and gas in a warming world. Today, she's going to speak about the Oil and Gas Climate Index, analyzing the varying climate impacts of global energy resources. Again, a very timely topic. Debbie, I turn it over to you. Welcome.
Thank you. Thank you so much, Bob. And also thank you. Shout out to Kelly for all of the, setups and arrangements to get this going. As Bob said, I'm going to introduce you today to the Oil Climate Index plus gas, the OCI plus, and it's an open source tool that assesses life cycle emissions from production all the way through to end use from the oil and gas sector, and can take a really in-depth look at global resources. So just to start out, and I think this often gets lost on people, that oil and gas are most often extracted together. So even though they will end up typically in different end uses, they have a lot of their life cycle and their value chain is intimately connected. And at least in the US, oil and gas account for about 80% of the greenhouse gas emissions that we put out. And when you add methane and other greenhouse gases, we're talking about a very large contribution from the oil and gas sector. The IPCC has most recently set a tighter target for climate change to reduce the increase in global temperatures to 1.5 degrees to avoid the damages, many of which we've started to see more and more with flooding and storms, and I think we're up to Theta now in the Gulf Coast, and fires that are taking off. And this will necessitate drastic cuts in greenhouse gas emissions. When it comes to oil and gas, specifically the IPCC, they were suggesting, although there were many different paths to reducing emissions to a safer level, they're suggesting that by 2050, one of the pathways was to reduce over 70% of the emissions from the oil and gas sector, which is a very tall order for oil and gas. It's something that you'll see in my presentation why my research focuses a lot on the supply side and not just the demand side. And the reason why I think in my 30 plus year career of working on, a lot of my work was on transportation policy and on fuel efficiency in the transport sector. And we haven't made as much progress as I had hoped all those years, because I do think that when I look at it now, oil and gas is just in everything. It's really all the stuff that we use in our daily lives. And you just can't simply replace everything on this list and thousands of other things with renewables. It won't be viable to have substitutes, say, for petrochemicals or toothpaste or paint or insulation of buildings with renewables. So the solution necessarily includes a look at the supply side, which is the production and processing and refining and shipping of these oil and gas resources. So I do think that the supply side hasn't received enough attention. We've been focusing for a very long time on using less, which is always a good thing to try to do when you have a problem, but it's just necessary but not sufficient. So in my mind, a picture paints 1,000 words. This is the image that brought me to the Oil Climate Index. It was this increasing heterogeneity of resources. And the question that came to my mind when I physically and chemically thought about oil and gas changing was, well, what does that mean for greenhouse gas emissions? I mean, if you're going to have, from the right-hand side of your screen, you're going to have oil sands that are the consistency of peanut butter, or even thicker. And then from the left side of the screen, when it comes to oil, something more like Pennsylvania crude, more like nail polish remover, and then getting into some gases that are more like cream soda, you know, kind of fizzy CO2 enhanced gas, then what does this mean for climate change? In other words, what are the emissions associated with bringing all of these things out of the ground and then turning them into all the things on the last screen? And my assumption was, my working assumption was that because these resources are so different and require so many different processes, they were going to have very different greenhouse gas emissions. So this is how we took off on this project. We were looking at, oops, go back one. Seems to be missing one. Anyway, I'll give you a sense of the OCI then and now. So we started with, in 2013, I actually did a presentation when I was at the Carnegie Endowment, and it was an unconventional oil symposium that was very widely attended, and we asked these questions. It was a day-long event, and one of the people I brought to that event with me to have on a panel was a colleague, Adam Brandt from Stanford University. He had developed a oil production greenhouse gas model that was being used by the California Air Resources Board in their low carbon fuel standard. And at that event in early 2013, we talked about not just using his tool to look at the greenhouse gases associated with a gallon of gasoline, which is what the Air Resources Board was doing, but to turn it on its head and actually look at the barrel forward and talk about all of the emissions that stack up from the moment you extract these resources to all of their various end uses. We brought in another partner from the University of Calgary who was building a model to look at greenhouse gas emissions from refining. That's the prelim model. And in 2015, we packaged these two models together and then added an end use module to make up the Oil Climate Index. The US Department of Energy used it to do their national petroleum greenhouse gas baseline. Like I said, the California Air Resources Board uses the production model. So these models have been very widely used and tested. In the first phase of the Oil Climate Index, combining all of these models for a life cycle assessment, we were able to model 5% of global oil production. We only started with oil. And in that 5%, we found over a factor of 2 different in life cycle emissions and a 10-fold difference in emissions between the lowest emitting oil to produce it and the highest emitting oil, and the lowest emitting oil to refine and the highest emitting oil. So we found huge variety from a very small amount of resources around the globe. In the second phase, we decided we wanted to make sure that that would hold true if we expanded the number of resources we were able to analyze. And in 2016, we modeled about 1/3 of global oil production, and it held. We found the same factor of 2 in life cycle emissions, and this huge variance in, if you look at the supply side emissions, the emissions that industry produces, what they call scope 1 and scope 2 emissions. In phase 3, in this past year, we added global gases to the oil climate index to assess mostly methane, and we found even bigger emission differences when you added global gases. In some cases, global gases that were difficult, unconventional gases that were poorly managed, had even higher emissions than oils, which I think really surprised us and a lot of folks. And now, looking ahead to phase 4, we are looking to model a majority of global oil and gases, and then also comparing these results with top-down satellite measurements and national emissions inventories, which we've already started to do. Just to backtrack here a little bit, the OCI covers these life cycle emissions that I was describing, just to see it here. And we account for and assess CO2 right now, CO2, methane, and nitrous oxide, and combined together CO2 equivalent emissions. And these 3 peer-reviewed models that I just mentioned, OPG for upstream out of Stanford, Prelim for assessing greenhouse gases for refining out of the University of Calgary, and then the model that I developed for all the transport of all the end-use products from oil and gas, and then the combustion or end uses of them. And that's what comprises the OCI. So just to give you a little snapshot of these results that we've had from the most recent expansion, the OCI Plus, it looked at 29 global oils and gases. This is using on a 100-year global warming potential. The variance gets even larger when you use a 20-year global warming potential, because methane becomes much more impactful. But you could see here with gases in red and orange and oils in blue and green, you could see a bit of the spread. And I charted this, it's one of the pages of the web tool that we have. I charted this and why it's aligned, because on the bottom it gives you a range of the emissions, the total life cycle emissions. But what's interesting is you look at the y-axis and it's what would it cost to produce a barrel of oil equivalent of each of these resources. And you start to see that even a carbon price is not so simple. If we're going to do a fair carbon price, you're going to be pricing some of these resources under $10 a BOE, a barrel of oil equivalent, and some, might be on the order of 30 or more if you're on a 20-year global warming potential, $50. And so this huge spread has to be brought out if we're going to actually reduce the emissions that are within each of these barrels that are quite different from one another. And another way to show you just some of the data that we came out, it's zeroing in on the responsibilities of different, whether it's consumers and a whole variety of consumers, whether you're a motorist or whether you're, an airline industry, or whether you're a petrochemical producer, lots of different end uses. But what I'm trying to show here is how many of the emissions for certain oils and gases, actually the responsibility resides with industry itself. This would be the scope 1 and 2 emissions, the direct and indirect emissions to actually produce, process, refine, and ship these oils and gases. And if you're looking at a higher greenhouse gas, you're over half of the emissions of the total emissions reside with the industry. And a big chunk, as you can see on the left bar, is in terms of its methane, those methane emissions from fugitives and venting. And it can go way down if you're on a low greenhouse gas, where most of the emissions are actually the responsibility of these variety of consumers and end-use consumers. And the same type of snapshot shows with oil as well, where, if you're a higher emitting oil in totality, you end up having a much larger share of your emissions reside within the industry. And what this shows is that there's really something in the short term to be done here. We don't have to wait to get off of these fuels, off of oil and gas, in order to reduce or mitigate the greenhouse gas emissions, because there are different ways and better practices to manage these emissions in scope 1 and 2 supply side. So switching now to some of the uses and how we've been able to use this information, the big picture is that having a tool like this provides these insights for investors. You know, there's a lot of talk about divesting and who to invest in, to industry in terms of best practices and how to actually turn around some of their the way that they operate now so that it has lower emissions and their direct and indirect emissions. Regulators, certainly I was showing you the chart with the carbon tax, you know, how you actually implement these regulations. And if you treat all oil and gas the same, you're not going to have nearly the impact than if you appreciate the fact that these emissions are so different. The research has gone into NGOs and with other academics that we work with and the public at large. So just to you know, summarize that the goal of this whole project was that oil and gas resources, especially unconventional resources, are abundant. We've seen that in the last several years leading up to COVID. There was no shortage of finding fracked oil and gas and oil sands. And we kept on, the harder we looked, the more we found, basically. But the more we found, the more different they were. And the lesson is that there are actionable opportunities to cut these emissions because oil is so different from itself and gas is so different from itself. So knowing these differences allows you to actually have much smarter approaches to mitigate these supply side emissions. So in terms of some of the ways that we've used the OCI, information disclosure has been a huge opportunity for us in terms of open source emissions, remote sensing. What we've been able to do both in Congress and also most recently in California is get legislation picked up called the Know Your Oil Act. And the idea there is to actually start to collect better data. A lot of our data is collected before unconventional oil really came to the fore in the last decade. And so there hasn't been this very specified detailed collection of, even for something as simple as what's the methane content of the gas. It's something very, very simple because gas used to be very conventional. And so its methane content was like 90% almost always. And now we're going for resources that might have methane content that's 60% or 95%. And when it leaks, that methane content is a very big determinant of what the methane impact will be in terms of greenhouse gas and CO2 equivalent. So the Know Your Oil Act idea, which will hopefully expand to Know Your Oil and Gas Act, but knowing these resources better and collecting better data is a huge part of information disclosure. I've been working closely with NASA. They have a carbon monitoring system, and we're using a lot of their top-down, you see the map here of methane from a Japanese satellite. We're using a lot of their top-down measurements to reconcile the bottom-up of what we can assess is coming out of these sources on the ground. And they need that data to actually interpolate and do inversions of the satellite data. So merging this bottom-up oil climate index with the top-down satellite is proving to be extremely valuable. We recently did some analysis together and are working on a paper on a blowout study in Texas, and we were able to line up almost exactly the emissions from my being able to model the bottom up with what the satellite saw from the blowout over the course of a month in 2019 from this field that had a blowout in Texas. And globally, we're working with the Rocky Mountain Institute and others to reconcile oil and gas emissions, again, using the OCI and different satellites. So information disclosure is going to be a huge boon to what we can do here so that we don't have to do everything at once. I think what this really helps us do is know where to point to the best specific option to reduce the most emissions the quickest. In terms of market rules and incentives, the OCI can inform, as I said earlier, smart carbon taxes that can fairly price emissions according to their life cycle greenhouse gases. If you put a single price on all barrels of oil, for example, what you're doing is you're sending the message to the market and to operators that, you know, those that are over, you know, they have higher emissions should just keep on doing that, and they're not charging them that fair price. So having this message come very clearly to operators that you're going to pay for the actual emissions you put into the atmosphere, and we could test that with these bottom-up, you know, models like the OCI and top-down satellites, becomes a very powerful tool when put together. I was able to also reconcile financial disclosure of climate risks to help guide investing and divesting with oil and gas assets. The more that we can give information to markets and to companies and to efforts like the Task Force on Climate-Related Financial Disclosure, the more specific they're going to be in being able to not treat this industry as one unified front, and to actually have very healthy competition within the industry to say to operators, we really want to do business with those that have the lowest emissions. In terms of regulatory action, I wanted to draw out, because it's really where I started the whole project. I had noticed that there was, as we were taking a lot of heavy oil from Canada to put into our refineries that over the course of the last decade have been retooled to handle heavier and heavier oils that had happened before we started to frack, I started to notice that there was this solid residue called petcoke that was coming out of the bottom of the barrel. And it was so dirty. It's like coal. It's the solid part of oil that you wring out of all the liquids you were able to produce at a coking refinery. And it wasn't accounted for because it's not a liquid and no one really recognized it as coming out of the oil sector. And I started to analyze it and understand and quantify using these models what exactly this meant for the emissions in the whole barrel. And in these conversations back and forth, when the model was evolving, at least one company up in Canada started to sequester their petcoke and use it for reclamation in their tailings ponds rather than exporting it to China and India to burn it. And it's dirtier than coal when it's burned, which is what's so scary about it. And it's much higher in sulfur, so it breaks scrubbers. There are a lot of problems with petcoke being burned for fuel. Following on that, India got on the bandwagon, and their Supreme Court a couple years ago banned the use of high sulfur fuel grade petcoke for power generation. So you could see how this kind of information finds its way into very important rules that can help when really what might be happening a lot of, especially developing parts of the world and countries that are really growing up quickly, is the cheaper the fuel, the better, when in reality, sometimes the cheaper the fuel, the much more dangerous it is for you. And in the case of petcoke, that was the case. And in terms of regulatory action and informing strategy, when I was asked to testify a few years ago when the crude oil export ban was being lifted, I was able to transform the knowledge that I had from the OCI into, saying to the legislature, well, really, these resources, the OCI can show us, like quantify that these resources are so different in terms of their emissions, but that means that they're very different in terms of their value propositions. And they, even those regulated or Congress people from states that were producing oil started scratching their heads and asking themselves, are we giving away good stuff and taking bad stuff? Trying to make them understand that it wasn't just climate that was at stake here. It's also an economic prospect. And it had them really start to think about oil differently, not as only one thing. And then the last thing that I wanted to focus on, because I think it's the thing that I'm most hopeful about, is innovation. Where are we on this, in this whole affair of oil and gas? The challenge with the oil and gas sector is that it is over 100 years old. This is a very mature industry. It needs to innovate to survive, but up until now, it's been a pretty monolithic industry that produces mostly gasoline and diesel at the highest value. We're seeing this change dramatically during COVID and turn things on its head. But we know that we need a net zero carbon future, and the oil industry doesn't really know yet how to bring us into that. There are voices that are, thinking that maybe we should just, turn off oil and gas and get rid of this industry. And the reality to me is that there is a place for these companies in this future, because they really are those that hold the capital right now. They're the ones that have deep pockets. And just a couple of examples of innovation in this sector that become kind of stepping stones to an energy transition, which is where we're all trying to go here, a clean energy transition. California, for example, has installed it is not California, it's a company in California, has installed the largest solar array that they're using to generate steam to inject into oil fields as an enhanced oil recovery. And you can argue that we shouldn't be producing any more oil, but the reality is, as I showed you much earlier, we're still consuming all these products, so we can't really stop producing all of this oil anytime soon. That's a whole transition that we're geared toward. So the idea of taking deep pockets in the oil industry and cross-training their workforce to run huge solar arrays, as is pictured here in the center, even if it is to generate steam for enhanced oil recovery, to my mind is a transformation. And I think it's a very important transformation. It's putting renewables in the center of oil field operations, which is a very important part of this transition. As I said before, I don't know what the future holds, but I wouldn't assume away writ large the oil industry as part of the economy in the future. I think if we want to get to clean energy, the oil industry is going to be part of that, and mostly because we need a lot of the things, we will always need a lot of the things that they make. Another example is Repsol in Spain announced last year that they are planning to make green hydrogen, which is hydrogen from renewable energy, most likely water and electrolysis and solar, but it can be from any number of renewable technologies that are under development, that they will use green hydrogen. And you've heard this before, energy companies talking about hydrogen, but what was different to me about this announcement, and I really hold it out as a hopeful prospect, is that Repsol was going to use that green hydrogen in their refining operations. Refineries are the largest consumer of hydrogen. And right now they make hydrogen by steam reforming methane. So what they do is they produce extra gas and to then strip off the carbon that they then pump into the atmosphere as CO2 to create hydrogen. And this is called steam reforming methane, and it's very cheap and it happens everywhere. They use that in their refining operations. So in other words, they're generating a tremendous amount of CO2 just for an input for their refining. And to see a company like Repsol announce that, no, we are rethinking our refining. It's really kind of turning around a very old industry that, to my mind, is the linchpin of the future of an energy transition. We're going to use green hydrogen. We're going to be purveyors and producers, not only of a product to sell the world, a carbon-free product. We're going to actually use it in our own refining, which to my mind is a multiplier effect in terms of transforming this entire industry. And then the third example I'll give is this, again, with refining, but it's the idea of a lot of the announcements that countries have had and companies have had up to this point of jumping to electric vehicles. And the idea of electric vehicles to me is really interesting because, of course, it's fantastic to take tailpipes off the road. For air quality alone, it's a great thing not to have tailpipes that are polluting, having millions or billions of tailpipes, especially in the developing world and especially in the largest cities. But combining that with refining is really important because when you displace gasoline, what you've done is you've taken one of the largest profit centers out of the refining industry. So if you combine a vehicle electrification with decarbonization and a whole remaking of refining, you've really started to chart what I would argue is the nut to crack with this oil, and I will say gas as well, transition into the future of changing how we actually can still make the things that we need to make out of oil and gas, because we know some things like gasoline will go, but things like jet fuel or petrochemical feedstock are going to be much harder to find substitutes for. So with that, I wanted to leave plenty of time for Q&A. I know often there's not enough time and there are great questions. I'll point you to the OCI Plus preview web tool. I showed a couple of graphs from there. Everything is residing on the oilclimateproject.com website, where you'll find not just the OCI web tool, which is open source and you can play with it and use it and do scenarios on it, but also there's information, all of the journal articles we publish, there's information, there's demo videos there. There are lots of articles and case studies. So feel free to go and send questions back to me. I'd love to hear what you think.
Thank you so much, Debbie. That was a great presentation. And I'll encourage the audience, if you haven't done it already, to look into the bottom center of your screen, the Q&A button, and feel free to submit questions to us, to Debbie about things that have come up for you during the presentation. While we're collecting some of those questions, let me start with a question relevant to one of your last slides there, and what the oil and gas industry is doing as they shift. One thing we see a lot more of these days is the use of CO2 for EOR. We see that in large ways. Most of that CO2 for EOR is recovered because it's valuable, but increasingly companies, I think Occidental, for example, has committed to direct air capture and then leaving a lot of that CO2 behind. So doing the flooding in a way that is a negative emissions technology. Do you have ways to factor that into your index? And I know none of this is at scale yet, but do you see some promising changes in emissions from these products just because of the sequestration capability?
Yeah, so we did decide when we were picking these about 30 oil and gases that I showed you in that graph with carbon tax, when we looked at those, which ones to model, we did decide, Bob, to model CO2 EOR two ways. One way was, I'll say, the better side of CO2 EOR, which Oxy is getting into, and the United Arab Emirates they're working at a steel plant to sequester flue gas and use it to inject CO2. And in that case, there were negative upstream emissions, which added to refining emissions that were not negative, and then end-use consumption emissions. And it brought down the total, because that first leg is negative, because you're basically sequestering CO2 to produce a barrel of oil, that it ended up bringing those emissions way down. It was a huge reduction in life cycle emissions. We then also modeled what I will give as a very, and these cases have historically existed and have to turn off. We modeled a case in Wyoming, a field called LaBarge in Wyoming, that there's an oil and gas field that are next to each other. And the gas is about 60% CO2. It's not a gas field that you would ever want to produce, but you would produce it if you wanted to increase your oil production. And so to my mind, that CO2 EOR was removing a naturally stored product out of the ground. And so in that case, you're actually non-economically producing gas to get enough CO2 to make money on oil. And those emissions were much higher. So what you could see in the OCI, if you go on the web tool, you can compare these two EOR projects of flue gas, direct air capture, versus natural, which I'll call is taking CO2 out of natural caverns. It's already stored, but I'm going to take it out and put it back in. Those very two different cases, and they are dramatically different. So I think that when it comes down to enhanced oil recovery using CO2, the devil's in the details. How do you do it? And which CO2 are you actually using? And you can't blur those lines. It's dramatically different.
Yeah. So as I look at some of your early results you presented, it's clear oil and gas have a wide range of LCA impacts. Given that we're not going to have a step function in oil and gas consumption globally. It's not going to all go to zero instantly. It's going to be phased out over time. How do you do carbon pricing in a way that gets us to phase out the worst stuff soonest, so that we can get the most out of our reduction in use of oil and gas in terms of CO2 emissions reduction, and we're left with the last stuff we're using in the end is the lowest emitting value chain. Anyway, your
Yeah,
thoughts on that? Yeah.
yeah. I mean, prices, when you don't have prices, there's no information. But when you do have prices, you want it to be good information. You really want to impart decisions that are structuring the market so that you get actors to behave properly. And the idea of this race to the top, so that you are actually pricing the fair emissions from these very different barrels of oil and gas, I think will speak volumes in terms of, if I'm an operator and I'm putting out enough CO2 equivalent that prices me at $30 a barrel of oil equivalent, I'm going to have a far different economic prospect than if I'm a very low emitting, I have easy to access, oil and gas or gas. They don't need a lot of work to get them out of the ground, and I'm managing them using best practices. If you're using all of the right tools and you are lucky enough to have really favorable resources, and you are going to be paying $7 a barrel in a tax, say, or a fee, you're going to have very different prospects from someone paying $30 a barrel. And I think that the market will structure that just naturally in terms of who's competitive in the marketplace. If you unfortunately do what we've been thinking about up to now, which is if you price all oil at $10 a barrel, say, or all oil at $5 a barrel, it's all the same, then what you basically said to the operators is, you don't need to do anything. It's all going to be passed down in unison to consumers. They're going to pay 25 cents a gallon on gasoline. That you wouldn't believe how small the margins are when you take these like large life cycle, like $40 a ton is something like 25 cents a gallon, or some very small amount that honestly there's more fluctuation on a weekly basis at the gas pump that I won't even recognize as a motorist. So if you price them all the same, what you're not doing is structuring the market. So that was the idea behind the smart tax that I worked on with my colleague at Carnegie, Jessica Matthews. We worked on trying to structure the price so that you actually take into account these scope 1 and scope 2 emissions, and you price fairly so that we can get the market naturally to say the dirtiest barrels should turn off first.
Yeah, great. So what kind of feedback have you gotten from the oil and gas industry? What's their reaction? Does it scale by who's emitting the most, or do you get uniform? Do they find it helpful to their own
Yeah,
operations?
they do. So I'll give you a couple of examples, actually. When we first were getting ready to release phase 1, Chevron was actually reviewing some of this, because Chevron was a big part of the low carbon fuel standard because they're a California oil company. So they were a big part of the Air Resources Board and OPG. And we said to them, we put the temperature settings on a heat exchanger at these 2 set points. And they said, well, we don't use those set points. We use these 2 set points. And we said, but if you use these 2 set points, your emissions upstream in production will go down 10%. And they did. So, you could see that some of these very fine-tuned operational decisions that you don't really think to question necessarily, because, and I will say why, and having worked in the oil industry early in my career, when you're in the oil, at the field level, and even if you're an operations manager that's dealing with environment, that is not your number 1 priority. Safety is your number 1 priority, and production and volume is your number 2 priority. And of course you care about the environment, you just have to with regulations, and no one wants to be called out, but it's not something that you're going to necessarily think to ask. How should I test whether these temperature settings will reduce my emissions? The other example I'll give you was when we released the OCI, there were a couple of countries that came out very low. This was right around the Paris Climate Accord. And Norway came out and said, we have the cleanest oil, and because of that, we should be able to go to the Arctic because we're such good operators. And there were infights going on in Norway, and it was Statoil at the time, now Equinor. There were infights there, but then it turns out that while Equinor was quite low, and they are one of the better operators with some of the easiest and the best practices, they electrify their rigs offshore, they reinject all the gas, they don't flare except for in an emergency. They do a lot of things right. But actually, some of the Saudi crudes were lower. So it created this bit of a fight of who's better and are you so responsible? But what was so cool about that was Equinor invited us in to do a reconciliation of their practices, like kind of a head-to-head of how are we modeling you and what are we really doing? And again, to kind of do this idea of, are there things we're missing here? On both sides, on how we estimate what you are doing and how we operate in the first place. So I think that there are some very important real world lessons, not because the oil industry doesn't know what they're doing, it's just that climate change is just one more thing they have to do.
There's a couple of layers to some questions about scope 3 emissions. As you can imagine. Um, so who's actually responsible for that, right? Should the oil companies take responsibility for that, or should consumers take more responsibility for that? I think in one of your early graphs, you showed data illustrating that the fraction of emissions from a particular hydrocarbon resource that's scope 3 versus 1 and 2 is quite different depending on the resource. So is there a way for, if a consumer is going to take responsibility, is there some way for them to know which ones of those sources have the lowest scope 3 emissions?
So scope 3 emissions are largely moderated through the refinery. So production has nothing to do with scope 3 emissions. I mean, you'll have scope 1 and 2 emissions to get the stuff out of the ground and pre-process it. But once it goes into the refinery, that refinery has its own emissions, which are also scope 1 and 2 for whatever company is operating it. But those refineries are what turn out on a daily basis millions of barrels of scope 3 and what will be scope 3 emissions, whether they're gasoline or diesel or jet fuel or petrochemical feedstock or lubricants or waxes or asphalt or any number of things that come out. And every one of those scope 3 emissions is kind of assigned to a different consumer. You know, if you're going to be, if it's a jet barrel, a jet fuel, it's a whole different scope 3 than if it's, you know, a trucker or, you know, a boiler in your home that runs on heavy fuel oil or some sort of fuel oil. So the scope 3 emissions, to my mind, are only going to become more and more important as we undergo this energy transition. This is the idea of what is the future of the refinery? How are we going to decarbonize refineries? How are we going to start to back out different volumes of oil and gas in this whole value chain? And if and when we get to a point where oil and gas is just making a much smaller kind of array of things, it's going to be much easier to distinguish those scope 3 emissions. Right now, it's just, I mean, you think scope 3 sounds simple, but the reality is it goes to so, as I showed in that very early graph of the products that oil and gas make, it goes to so many consumers. I would argue there are hundreds of refineries in the world. It's probably the smallest N in the whole value chain is the hundreds of refineries. There are thousands and thousands, tens of thousands of producers, most of them in the United States because we have that kind of an oil and gas industry, whereas the national oil companies have fewer in other countries. And there are billions of consumers. So if you look at this kind of array of scope, of, you know, how do you get to scope 3? I would say if it is a low emitting upstream scope 1 and 2 oil and gas, if we get to that pricing where we know those barrels are coming out first and foremost, the really low emitting scope 1 and 2 barrels, then it's really on the consumers. It's very much on the consumers to just sip fuel and be efficient and do everything they can. But first we have to get, you know, really deal with these high emitting upstream, midstream barrels that are coming out of the ground because they can dwarf the emissions from, you know, the other barrels very quickly.
Yeah. So here's a question about, first starts with just a comment that it's great that you're classifying oil types as more or less polluting in terms of greenhouse gas emissions. But do you also look at other pollution, other environmental impacts from production of those hydrocarbon resources like coal or shale oil extraction, or PM 2.5 emissions that cause health impacts, beyond the CO2 emissions or methane emissions.
Yeah, so in terms of the types of resources, the shale part of the question, we're not looking at coal. It's oil and gas, but it's all different types of oil and gas. It's fracked, which would be the shale resources. It's heavy oil. It is conventional oil. It's sour gas. It's acid gas. It's ultra deep gas and ultra deep oil. It's all of those different. It's really any resource that we can get any information on, we can model. And it doesn't just have to be a resource that's actually being it's in production now. If there are prospective assets that are due to be developed, we can actually model and estimate what the emissions will be if a company decides to go there, which I think is an even more important question. It's harder to turn something off. It's easier not to turn something on. In terms of the pollutants, we haven't brought it to the front yet, but right now we have VOCs in the model. They're not at the front end of the model. On the refining end, we have air toxins, and we have SO2, sulfur, sulfates. And it had always been my hope, because I do think not really for the US, although it's important here, but definitely in the part of the world that's really consuming more and more oil. If you look at India and China and where these refineries are being built in Asia, air pollution is a huge problem there. So it's been my desire to triangulate air pollution and climate change, and so many of those pollutants are co-pollutants, that my hope is to build out the models so that you can model both CO2 equivalent, which is methane, which is a precursor to ozone, and CO2, and also NOx, but then also do particulates, which is black carbon, which is both a greenhouse gas and an air pollutant. And you can model volatile organic compounds and SO2. You can start to model these things together and look at it from an air quality perspective and a climate perspective.
Great. So I don't think we've touched yet on a different kind of product, LNG. And one of the questioners asks about LNG, if you've factored that in with your index and you've learned things you could share with us about different ways of producing the gas, liquefying it, exporting it, regassing it, and so on.
So LNG goes in the scope 1 and 2 side of the equation, depending on who's holding, whether you've sold your gas to, a shipper who will do all of that, liquefaction and regasification, or if you're doing it yourself. But it's definitely in that scope 1 and 2 bucket. And we did model it. You'll see in the OCI web tool that you can play with, there's an LNG switch. And it's really an interesting situation, because the old world of regional gas supply, where you use pipelines, has the potential to be much lower emitting as long as they don't leak, which can be a big problem in the gas world anyway, whether it's end use distribution or just in terms of moving gas to, hub. And it still can be lower emitting, because you still need those pipelines to get the gas to an LNG facility. So you don't really obviate that. You just don't maybe move quite as far unless you're, a CNG, a compressed natural gas distributor. But when you actually do LNG, it becomes pretty dicey pretty quickly. And I don't know that we'll ever be able to turn, it's hard to get the genie back in the bottle. Once things globalize and markets form, it's just the reality. And we were in the US planning all these gas import terminals until about 5 years ago. And now we're all about gas exports, and certainly Europe and Japan and others want our gas. And so making sure the LNG is extremely low emitting and incorporating renewable inputs for energy inputs as much as possible are going to be really important, because when we've modeled LNG, it can add 30% onto the scope 1 and 2 emissions of the gas supply chain, which is not minimal. It's material that we're going to be increasing emissions by moving gas around the world unless we're really careful about it. And because the industry is just growing up now, it's the right time to be really careful about it.
So here's a question about the carbon circular economy. Do you see that as the way forward in this this industry, the oil and gas industry, or how do you see that with, and can you get a window into that with your index?
Yeah, so I mean, I've thought a lot about this transition strategy, and it goes kind of beyond. I see the oil and gas climate index as being this midway of how do we navigate this midterm that we're in right now. We know climate change is a huge concern. We have to deal with it. A transition is going to be maybe into the future and be under planning for a long time, which is where I'll get in a second on the circular economy. But the idea of just managing those resources that we're relying on right now is an opportunity that we can't afford to miss. But the circular economy to me goes into this, what we're planning into the future. And I have long believed that the linchpin of all of that is hydrogen. That the idea of being able to both produce and also take CO2 out of the atmosphere and then create and go backwards on the combustion, instead of going to CO2, you take CO2 and hydrogen and you go back to materials. The idea of having this kind of circular notion of how we have an economy with all the things that are the stuff that we use today, I think that the go-between is CO2, hopefully mining it out of the atmosphere, where CO2 becomes the product that's valuable to consume taking it back from the atmosphere. And there's a lot of work, and I've done some work on geoengineering. I think that it's something, again, it's a whole new experiment. So we have to be really careful about these things and how we're going to do it. What we know is what we've been doing for the last 125, 30 years is we can't keep doing it this way with oil and gas and combustion and fossil fuels. And we're going to have to do something that goes backwards. And I see it as circular with hydrogen in the center of that.
Yeah, thank you. So as we look at smart ways to tax to factor in this your index, you were discussing sort of country winners and losers, the Saudis versus the Norwegians, who had the lowest emissions oil. What about within the U.S.? Do you see issues with states that are winners or losers? The questioner uses the analogy to high sulfur coal, where Appalachian coal, which our sulfur content lost out to Wyoming coal, much lower sulfur content. Do you see something like that happening sort of intra-US?
So this is really interesting. I think it was one of the, it wasn't a result so much as a constraint that shocked us when we first did, my colleagues at Stanford and Calgary, and I did the oil climate index. In getting enough data to model only 5% of the world's production, and we spent 2 years mining data. The majority of that data was from OPEC countries. There was more transparency and data available from countries that we can't really see. And the US was a black box. In fact, we could get no oil assays from Texas that we needed to run the prelim model. There was no information at that time on flaring. Now there's more, but it's still very difficult from North Dakota. I think that in order to do what you're saying, what the questioner was saying, and I think it's vital because we are now the world's #1 oil and gas producer. We're the #1 oil and gas refiner, and we're the #1 oil and gas consumer. I mean, we have this trifecta in this country where we kind of control it all. We're not independent, and there's still a lot of oil and gas trade that goes on our border to get the right stuff in the right places for the right price. But the reality is we are the only country that can claim all 3 positions. But in order to manage that and manage that smartly, we need data, we need knowledge. And that's what the oil and gas climate index has been trying to get to. But the lack of data, which is where that Know Your Oil Act is trying to get to, the lack of that kind of data is really problematic. I do think that there's hope. And I think that this very hopeful note, I'll say, I do think that as the last question asked with the circular economy and the assumption that we will come to a transition and will shrink and change demand, What's happening then is these oil companies have to compete more with each other. They're not all producing the same thing for the same market, for the same end use, the same prioritization as they have been for many, many, many decades. Like they're all producing gasoline, like that's what they do. They're going to start to differentiate themselves, both in terms of the resources they go for and the products they sell. And there's going to be probably a shrinking of how many millions of barrels circulate in the economy. They'll have to do that. And the idea of that competition to me brings out that data, because now you have an incentive to show what you're doing, because it's not like you're competing all on the same plane.
Yeah. So that gets to another question that was dealt with. How frequently is your data updated? What is the source of it? And a separate question, but related question is, do you have data on at just a national level, for example, Saudi oil, or do you have regional data within a nation?
So we have modeled, as you'll see if you go into the Oil and Gas Climate Index, we have modeled fields in the world, these different assets in the world. And so we have data that don't abide by companies so much, although in a lot of parts of the world, if you're a national oil company, those are your assets. But we have like Saudi Gawar, or we have Norway Ekofisk. These are like major, and I'll give you an example of a really interesting one, which was UK Brent. We tried to model UK Brent in OCI 1.0 in 2015. And we couldn't get enough liquids out of the field. At the time, in 2015, it was becoming a gas field. It's so depleted that we just threw it out of the model and decided that we couldn't model it as an oil field. We were able to bring it back into the Oil and Gas Climate Index and model it as a gas field, but it is blowing out. It's so depleted, it's blowing out so much CO2 that it's the single dirtiest field in the world we've been able to model. And this is like a 40-year-old oil field that the Brent basket is named after. It's kind of in the course of being decommissioned right now, but it probably should have been decommissioned back when we were first starting to look at it. So our data is very field specific, and wherever it is, it's not, they fall into different boundaries, but they're geologic field specific. And then it can go to any refinery in the world and be modeled based on the type of refinery that would take that type of oil. So you can change the refinery based on the processing equipment there, based on what refineries handle which types of oil. So it's very asset focused. It's not, you have to reassemble it to become company focused, because companies are into and out of assets all the time. They're always decommissioning, buying, changing, growing, shrinking, selling, going out of business. Things are happening all the time in this industry. So the idea of building it up from the durable carbon, part of what is where the carbon is, which is in the ground, was something that we wanted to do. And in terms of data sources, we've taken data from every open source. I spent weeks at the Library of Congress mining global data. It's a database that you can only get if you physically go sit in the Library of Congress. So you can't get it any other way. We have not purchased data because we've done studies using the model to vet it and publish a couple of the science article that we did in another Nature climate change that you'll find on the website. We've used major oil databases that are hundreds of thousands of dollars, but we didn't want any of the data to reside on that. So all the stuff you'll see here has open source data behind it that was been mined by journal articles, by company reports, by Library of Congress. I mean, any place we can get any data whatsoever.
Great, thank you. So we have lots more questions. This is MIT, and people are very interested in this subject matter, and we could go on, but we're at the end of the hour, and I want to thank you for a really interesting and engaging seminar on a topic that's just vitally important. I mean, we obviously, as you showed at the beginning of your talk, oil and gas dominate a lot of our energy mix today. We need to get emissions out of our economy altogether. We need to get to net zero, and doing that in the smartest way possible is clearly important and is well informed by your kind of research. So it's great to see what you've done here, and I want to thank you very much for taking the time to spend with us this afternoon to do this. And I look forward to getting you up here in person, and we can have some more face-to-face conversations with various groups around campus. I'm sure that they would enjoy that. Now, but before we stop the webinar altogether, I just wanted to call the viewers' attention to a few upcoming events at Mighty. There's November 9th at 1 o'clock. There's Analyzing Switch On, which will have Scott Tinker, Ernie Moniz, and Rob Stoner. And then on November 10th at 3:30, a seminar on valuing private car ownership and use in the U.S. By Joanna Moody. So stay tuned here. And once again, thanks so much to Debbie Gordon for just a fascinating talk and a stimulating Q&A session.
Thank
So
you so
all the
much,
best.
Paul.
I hope you continue to be safe in Providence. So
Thank you.
good. Thank you. Goodbye.